it, right? So when we say dot replace and we give it a character class of OU, we're essentially saying to replace things that have O or U characters, any character that is an O or a U with an A. And you can see here the example where we both have input and we have the output right below it. So this is pretty simple. Right below it, you're going to see this G. Anyone know the name of that G? What that we call that? Okay, and it fits into the name of we call those things flags. Those are regex flags, right? That's exactly right. It's the global flag. And that just means do it more than once. So if you don't provide the G, you only replace the first match. And if you do provide the G, you're going to replace all of the subsequent matches. So that's pretty simple there. Here where we have these, does anyone remember what the parentheses are called? We went over this one in the last class exhaustively. Parentheses are called? Grouping, that's a good way to think about them. That's right. You can call them grouping, that's perfectly fine. Most people do. Grouping, matching pattern, right? Capture pattern, all of those types of things. Capture pattern is probably the more typical one, and I think it's probably the more academic name for it, if anyone cares. But essentially there, we're saying capture. Anyone remember what the /W is called? Or what that means? Word. That's right, a word character. Now here's another one. What is it? What is a word character?
Any letter, any... oh, that's a good one.
Anything that's not white space?
No, that's a good guess. That's why I want to hit it up. Alphanumeric is a great start. There's one difference between alphanumeric and a word character. Anyone got it?
Well, carriers don't have
the underscore
numbers?
character. The underscore character. Alphanumeric has numbers. It's alphas and numerics, right? Alphabetical characters and numeric characters. But yeah, pretty much when most people see it, they're going to think alphanumeric. But just be cautious that W is usually in that group too. Okay, so we're saying here, match, what is a plus? We haven't went over that today.
More than one word.
More than one character, that's right.
More than one character.
Right, so one means you need to match one or more characters, right? So what we're saying here is match welcome. I got your message on Facebook too. I didn't know how we're gonna do the
On Facebook. I'm banned on Facebook.
the streaming thing.
That's
Texting, yeah. Awesome, you made it. I don't have to worry about that. We're going over the last chapter, so we're kind of like summing regex stuff, summing up some regex stuff. Okay. So what we're doing up here is we're saying one or more word characters followed by a comma followed by one or more word characters, right? Welcome. So we have in that the right-hand side, right? We have the capture patterns. We have the regex, which is right here. It's this part. So this is actually creating a regex object. Over here we have what we call the replacement string, right? So you have what you're looking for, your pattern, and your replacement string. Now, if we look here, the replacement string has a 2 and a 1 there, right? That's interesting. So what that is that's actually the respective positions with the captures, the groupings. So when we say 2, 1, we mean this guy and then this guy. Switch them in order. So if you look here, you have Liskov Barbara, but here we have Barbara Liskov. This is going to be the first match, right? Actually, Liskov is going to be the first match. Barbara is going to be the second match. And then what we're doing is we're not capturing the comma. And then we just switch that around. So we're reversing that order. That's all that we're doing there. Skipping the comma, getting it out of there, and putting the order backwards. This is the kind of stuff you'll do every day, especially as a junior level programmer, right? This is probably the single most important thing with junior level programmers to master is going to be regexes. Because so much of what you're going to be doing is text-based, or can be text-based, even if it's not supposed to be. Perl's a great example. You can do all kinds of shit in Perl with regexes because it's so damn useful. All of the stuff you can do in Perl with regexes, well, most of it anyway, you can do in JavaScript with regexes too. So you just start to think of your problem as taking in text input and putting out text output. And generally speaking, that will do a lot of businessy stuff, right? When someone hands you an Excel spreadsheet, you'll be able to make sense out of it a lot quicker. You know, I wouldn't parse the CSVs with regexes, but after you do that, that's really great. So here we have one where we're setting into a string, the CIA and FBI, great, two organizations we all hate. And what we're doing here is we're replacing anything that matches FBI or CIA, right? And we're replacing it with this, which is what? What is this guy right here? Anyone remember what this indicates? What do we call this?
Arrow function.
Not arrow function, but what's the other word we're using for it?
Fat arrow.
There we go, fat arrow, right? That's it. So we have a fat arrow, which implies exactly that it's an arrow function. This means we're taking in a variable, right? And we're producing this output with it. So we give it a variable string, and what we're actually doing here is replacing it with string.toUppercase, right? It's very logical what that does. In JavaScript, if you take any string and you call .toUppercase on it, that is a, just out of curiosity, you don't know the name of it? If string is an object, then what is this? Method. That's exactly right. We're calling the method toUppercase on the string. It just simply capitalizes all that crap. So what we're doing here is if we get FBI or CIA here, we match it, and then we simply uppercase it. So now we have this B guy here. We went over this in the last class too. What is B?
Boundary.
Boundary. That's exactly right. What does boundary mean?
Basically, it'll separate from white space to non-white space.
You can think of it like that. It's actually from word character to non-word character, but yeah, that's pretty much exactly right. You know? Okay. So here's an example. I just don't remember where we dropped off in the last class because it was somewhere right around the middle, and this thing just keeps going on and on. But we have stock
YouTube video.
Yeah, it probably isn't a YouTube video, but it's all good. So here we have -1 takes a match amount in a unit, right? So we know in JavaScript when we run .match on something, we get one variable back every time. We get this thing called match back, and match is going to be the whole pattern, right? Not just what you capture, but the whole thing. Not every language does this. This was a JavaScript thing. We went over that. But we're also getting back an amount in a unit. And if you look here, we call stock.replace, and we're giving it 2 capture patterns, right? So when we call this function here, -1 is what's going to get called as we match this. When we call -1, the first variable that we get is match, the second is amount, and the third is unit. This is the second, and this is the third, right? So the first thing that the function's going to get when you call replace is the whole pattern, everything that this matches, right? The second variable it gets is just going to be what this is, the first capture pattern. The third thing it gets is just going to be what this is. So the first variable is the whole match, the second is just this guy, and the third is just this guy. And all of that gets sent up here to this -1 function, right? Now what is it going to do? It's going to do some other crap. None of it I think is related to regex, but that's the fun thing about this book. So we come up here and we say number, amount, right? So we know amount is text. JavaScript can store anything in a variable. You want to make a text 5, a number 5, you call it on number. Now you can say -1 on it. So they're just simply casting this, which is going to be this guy here, to number, and then we're saying subtract 1. And then what we're doing is we're saying if amount equals 1, then there's nothing to remove, and if amount equals 0, then we simply prefix it with no, right? So when we give it 1 lemon, 2 cabbages, and 101 eggs, we get no lemons because we're subtracting 1 from 1, and we get 1 cabbage rather than 2 cabbage. Now look here, this is this whole removing the s thing. So if you have, when you give it all of these arguments, it assumes that if there's 2 of something, it ends in an s. And then this logic right here, if amount equals 1, because we just subtracted 1, we know we have to drop the s. So that's what this guy's doing. Remove the s. 1 cabbage and 100 eggs from 101 eggs. That's it.
Well, and this is where we stop.
Parser.
But
I think we skipped
Those are
that. That was
last
the
one.
problem. I think we jumped to that very bottom.
Okay.
Because I remember that we skipped greed entirely in the last class, didn't we? We did greed. We went over greed?
Yes.
Okay, I remember we tried to go over
We did
it.
AD and BA for bad.
We did. Yes, I remember that. Okay. Okay. So someone sum up greed. What do we got for greed? What is greedy? What does that mean?
Greed is if it will take up more characters of, for example, A will take more of the A's of the first, you did groups of the first group, and not the second one if there's, if it doesn't have any pluses, for example, on the A's. There's no plus at the end. Well, it's easier to show it than it is to actually explain it.
I totally agree with that. That's usually the case with code.
Takes priority for which match.
That's a good way to think about it.
Yeah,
that's
probably
nice.
better.
I would say it matches as many characters as possible as opposed to a non-greedy match, which only finds the basic match.
That's exactly
So,
right.
yeah.
So I want to make sure. I want to go over this quickly, but I still want to go over it because I can't stress how much regexes literally are going to be so much of what you do at the beginning. You know, no matter where it's at. So let's just hit this really quick here. What we're doing here is we're stripping comments. When we're stripping comments, this one should make total sense to everyone. We're looking for 2 forward slashes, right? That's just your typical JavaScript comment, right? This is a great example of a comment right there, right? So we're escaping them. We escape them with the slash itself. And then we say, this is a comment. This would be a comment of this type. Right, now we have these types of comments. This also makes sense. These are your typical C-style comments. So you have the asterisk comments, and we say whatever's in the middle of them is a comment. So this would get parsed as 1 plus 3, right? Because the slash asterisk is removed. Right, now that makes sense. And again, here we have the same type of thing. We want to remove the //10. Here's a tricky one though. This is a great example for greediness, right? And we really struggled to come up with an example and get away from what the book did in the last class, because what the book did was crazy. But this is an actual example from the book that's pretty decent. So here what we have is we have an A and we have a B. And this is where greediness comes into play. This is a clear, concrete example. If this is greedy and you match this, you're going to skip all the way till the ending one. And what you want to do is just match what's inside of the closest one, right? So you don't want to gobble up everything until you find this pattern, right? You want to just gobble up and this until you find this pattern. So here what we're going to be doing with this is we're going to say if we have the question mark at the end of that pattern, that quantifier, dot star question mark, just gobble this up, and then this will be the second pattern. So when we look at it, I think he's going to show it right at the bottom of this. Let's scroll down a little bit. So here's what he's doing here. Let's go through it. This is the part that triggers it, right? So what we have here is this is escaping this character, right? So we have an escape for that character. And then what we have is we have an escape for the asterisk. We're escaping the asterisk. And then what we're saying is we don't want here we use the blank, any character that is not in the empty set of characters. That is such a stupid way to do that. Okay, he's saying essentially this is the same thing as this, right? That's what he's looking for, to keep it simple. So we're saying anything there, now that's the non-greedy quantifier. Non-greedy. Rather, that is the greedy one, and what we want is the non-greedy one. So if we come down here, this is the difference. The difference is that when he does it the right way, he shows you the wrong way first. He implements this. This is the mechanism right here, which we use to turn off greediness in the regex. Right? The asterisk question mark makes that non-greedy. So when we do that, we're only going to be matching the inside of it. This, we're not going to be gobbling from this point all the way to the end. All right. I don't know what else to add to that for the greediness thing. If we have any questions on that, we can go over it again, but we're just trying to sum up what we showed in the last class. The parse INI stuff is how we finished it. All right, let's go ahead and look at the examples here. Okay. There we go. Okay, let's do this here now. So the task that we've been given is we're going to, when it gives us car and cat, we need to create a regex that matches both car and cat, right? And then we look down here and we have a verifier. And this is like a testing suite that matches, we want it to match car here and cats here. And we want it to presumably not match camper and art, right? So let's take it and we're gonna and the reason for this is I think this is one of the ones where he puts here's where he finds it. He must have found it up here. I am not sure where he actually supposed to define this verify function. Did anyone actually do this? Did he define the verify function anywhere? Or is he giving us a very
bottom? You go to code. So go to eloquentjavascript.net/code.
On mine, it's right below the verify. It's
Yeah.
right below where you are
Oh,
right now.
okay.
So if you click
there
on it,
we
you
go.
scroll down.
There you go.
Okay,
There it
I
is.
see. Okay, cool. All right, 2 scroll marks. So what we're going to do here is we're going to go through the first one, and what we want to get on this one is cat and cats. So this is simple. We're going to take it and verify. Let's say cat, car, and cat is what we need. So CA, R, and T, right? That's what they're looking for. And we know they're looking for that because they want car and they want cat. So the commonality there is that they both start with CA and they both end with R or T. So that regex there will match either car or cat, right? So we're using a character class in the last character. And now we're going to just paste in the rest of this stuff and hit enter. And I have no idea what that's supposed to match or how he's doing this. We're going to go through it. I'm going to ignore the top part. We're going to get through it a lot quicker. Look, prop or props, right, is going to look like this. We can go here, prop or pop. If we look at that regex right there, we're going to match P followed by 0 or 1 R's followed by an O and a P. Right? So that's going to match both of what they're talking about here, pop and prop. The next one we have ferret, ferry, and Ferrari. You'll see each one of these 3 starts with F-E-R-R. Right? So we have 3 different suffixes there. Right? E-T, Y, and A-R-I. And you're going to make that one look like this. F-E-R-R. And then we can say E-T, Y, and A-R-I. Just like that. See how we're doing that? That regex will match ferret, ferry, or Ferrari. So we're using the capture patterns there to do the ET, Y, and ARI. And we went over this in the last class too. Does anyone remember what the question mark colon means?
Basically you can't match anything in that group, or you can't print out anything in that group.
You don't capture it. You
Capture.
match it, but you don't capture it.
Yeah.
So the normal default behavior of this is to actually save that stuff so you can get it. So if we want to determine 6 or more characters, right, which is what it says, a word longer than 6 letters, we're going to do a word, and we want it to be longer than 6 letters, like that, right? So remember, the first argument inside of the curly braces is the minimum length, and the second one is the maximum length. So a word longer than 6 letters looks like that. Now we have to match 6 word characters. Right? Okay, and a word without the letter E or E. right? Now I'm still going off of a word character definition, but if I wanted to create the word character, right? If I want to show you what it looks like, we do this: A through Z, 0 through 9. That is the definition of a word character. That is the very same thing as this, right? And here's the catch: we don't want lowercase e's or uppercase e's, right? Because that's what they're telling us to do. No e's. So what do we do there? We're just going to take out e's. So it would be A through C, and then A through D, E, F, Jesus, alphabet sucks. A through D, and then F through Z, and like that, right? Now we have a gap in there, or we're not including the lowercase e or the uppercase e. And it's that simple. You can just create that range just like that. Cool. All right. Now that finishes that whole example. And I didn't want to, we could have obviously ran it through this little thing and got it to work, but I have, that's just beside the point. I know that this is going to work. So we have here quoting style. And now what we're trying to do is we are trying to, let's go here, boom. So we have this string, text, I'm the cook, he said it's my job. And what we want to do is we want to make it look like this, where we're double quoting it, right? So we have a single quote here, I'm the cook, and what we want to do is we want to make this single quote a double quote. But here's the catch. We don't want this one to become a double quote because that's an apostrophe. So sometimes you have single quotes that quote stuff, and sometimes you have single quotes that are apostrophes, right? So that's how it is in code. And what we want to do is change it. So what we're going to do here is we're going to use this line here, and we're going to fill it out. So what we have to do is give it something here with this A and replace it with something here. Now we know what we want to replace it with, right? We want to replace it with a double quote. So we're going to do that. That's a double quote. Now what we want to do is we need to capture the single quotes. Now watch this. If I do it like this, right, this is a failure because if I look here, this is there. And that's what they don't want. So this is the tempting solution for you to give, is to replace all of them, but we can't do that. So one of the ways we can get around that is we can take it and we can essentially say we want to capture the stuff in between the quotes, right? Or we want to look for specific quotes. Those are our two options. To determine what is a quote, and then simply capture the very same things with double quotes, or to simply specify we just want to replace some quotes. So we have two different methods of solving that problem. Now if we look here, we can see that this is the original string right here, right? It would be kind of difficult to determine what to capture inside just based on the word character, right? Because this is a single quote, this is the character I, and this is a single quote, right? So if we make it non-greedy, we capture just the I. If we make it greedy, we capture a bunch of stuff, right? So we have to be specific then about what the quote is, right? That's the trick here. The trick is we have to say what a quote is that we want to replace, because we don't want to replace them all anywhere we cut it. Okay, so what we can do is we can say here, we want to replace just the quotes that are at the beginning of the string, right? Just to give it preemptively right there. Now we went from text, which has this quote, to text, which has this quote, right? So I'm gonna clean that up a little bit. There we go. So text and our text.replace. So we're not doing what we want, and we're not doing what we want because we are just simply replacing this guy with this, and that's leaving a lot of other work to be done. But what's important is that's one thing we want, right? It looks like we have a question in back.
So you just check to see if it's not a leading trailing character.
That's where we're going to go with it, yeah. But it's a little bit more difficult than that because look at the first quote, right? The first quote isn't a leading or trailing character. Well, I mean, the first quote is the very first character, right? But we have to find a way to where we differentiate between this quote, which we want to replace, and then this quote, which we don't want to replace, or this quote, which we don't want to replace. So we're looking for methods in which we can do that. So we say here, essentially, we're looking for things that we can say start with this or a space, right? Because both of those we want to replace. And if I hit enter here, we'll say we have one more now, this one that we've replaced, and we want that. But here's the thing. We want to, if we see this, we've lost now the white space character. So we got to put that back. So we say here, $1, right? Now we have our white space character back, and we've replaced the quote that we want. And now all we have to do is get the quotes on the other side, right? This one, which has a space character on the right, and this one, which has the $sign on the right, the end character, the terminal character on the right. So what we're going to do is we're just going to simply put the or here, and what I'm going to say is I want to catch the quote character followed by the end character, the last character in the string, or a space, right? Now if I look at it, I'm doing exactly what I want, right? I'm matching the first character. The first character is a single quote, we replace it.
But you got the double quote E missing a space.
The double, oh, hold on here. That's a good catch. There we go. Now we've solved it. That's a good catch. I like that, because he's paying attention and I made a mistake. So it's twice over good. What we're looking for here is we're looking for the first character. The first character starts with a quote, we replace it. If the last character ends with a quote, we replace it. And if either one of them has a quote, a space before or a space after, then we know it to be not an apostrophe. That's how it works. That's how it works. Now, in other languages, you could probably do that a different way, but in JavaScript, that's pretty much the only tool in the trade in the book on this one. And okay, last we have this, and this is going to be the last one that we're going to do. And then we are done with the regex chapter. The module chapter is going to be pretty easy. So there's only like one code example in that. All right. So I paste all this code here at the very bottom. And you can see that's a bunch of crap. So what we're going to do is I'm going to define something sane with this. Let's get out of that. And I'm going to say here, function g equals, and I'm going to paste all of that code in there. There we go. Okay. So I'm going to show you what I did. He has this. He's essentially given us two different test suites, right? And this is the problem I had with the last one too. I want to have the easy ability to rerun these tests. That's what I want, right? So if I run this for statement and then this for statement every time, I can retest all of his code. And that's really what I want to get done. The big problem here is that I don't want to have to keep copying and pasting this in because it is seriously screwing my day in my terminal. So I'm going to create a function that does this for statement and then this for statement. And then what we're going to do is we're just going to change the definition of number and call that function, right? So we can change the definition of number, call that function, see what works and what doesn't work. Then we can change the definition of number again, call the function, and again see what works and doesn't work. Now, here's an interesting point. When you are a programmer, not a junior level, when you work in an actual company that does things the right way, what they're going to do is have something called test-driven development, and this is exactly how it works. You're going to change something, in this case the environment, the number, and we're going to rerun the test suite, right? So I want to check one thing here, because I probably screwed that up. And yes I did. I don't want number in there. So here, we're clearing that out. Node, we'll say here function test. And now what I'm going to do is come back. We're going to copy all this stuff right here. Copy. We're going to go over here, paste. Then I'm going to end it. Now I have test. I call the test function. I just simply have to define a number. And now I can call the test function, and it tells me how everything worked, right? So now all I'm going to be doing is changing number and recalling test. Changing number and recalling test until it stops complaining, right? And we're going to actually see how we create this. So right off the bat, what we want to do is we know we want to match a digit, and we know we want to match either a plus or a minus, right? And we want one or more digits, right? So something like that. Now this is just a first attempt here. Now if I recall test, you can see all of that crap at the beginning has substantially shrunk. And now this is all I'm getting, right? So look at all of these ones before that I was incorrectly accepting and the failure to matches, and they all went away. Now I'm just getting this, right? So right off the bat, that little regex cleared up a lot of the failed tests. Right now we just have to catch this stuff. So if I come up here, it says failed to match the 1. That's because I forgot to put the question mark there. I was making that plus or minus required, I want to make it optional, right? So if I do this, I'm good. But we'll see here we have some of them with these 0.55s, decimal points, floating point numbers. So we're going to have to match that too. So let's do that, right? I'm going to ignore the question mark colon thing, which turns off the capturing and just makes a grouping. We already went through that. If you were to write this professionally, you would certainly use that in all of these. We're just going to ignore it. So now what I'm going to be doing here is we have to have a decimal point, and then we have to have one or more numbers on, well, no, because this guy works, right? We just need a decimal point, right? And then we can have one or more numbers after it. So I throw that in there, right? And I'm going to recall test, and it got smaller, right? It got smaller because we lost this guy right here, but now we picked up this guy right here, right? So what we have to do is we have to fix it up a little bit. So we need to be able to match now either something with a decimal point, or we have to match decimal point something. So we're going to move this out, and what I'm going to do here is say we can match like this, or what we can do is we can match like this.
Maybe that first question should be a star.
Once you just put a star.
Let's see if that worked. See? Okay, what was the question? By the way, this is not a very good regex. I'm trying to show you how this would get done and keeping it simple to get it done. Yes.
The first slash D plus
Mhm.
is maybe a dash D star.
You just put a grouping there as a star, so it would be 0 or 1.
What I'm trying to say is that we have two different testing and failure points here. One of them where we don't have anything before the decimal, and one of them where we don't have anything after the decimal. I'm
Okay.
being
I see,
explicit here that in the one on this side right here, where we're matching one or more digits, right, we're being very explicit.
Okay.
This one's going to match digit, point, maybe something, right? This one's going to match maybe nothing, point, definitely something, right? So we have two different cases, 0.5 or 5 point, and I need to match both of them. And here's the thing, if you look here, right, we've introduced another thing, which is this. We are not matching this guy or this guy. This is very simple. Why are we not matching it? We're not matching it because it's hitting this pattern, right? It's definitely on the left-hand side, but this isn't optional. Okay, so let's make that guy optional. This is not complex there. We're just, well, too stupid to use a terminal, but other than that, it's not complex. We're going to put this in parentheses again, and question mark, right? Come back, run it again, bada boom. Now that's a ton easier, right? Now we're down to three failing cases. This is what they say when they say test-driven development. We have shrunken the amount of failure to a very small amount. And at this point, we have to implement scientific notation. So how are we going to do that? Well, everything here is working out okay, but we're at the end here. We can't match anything because we have the $sign. That means the end of the string. And we're supposed to be matching this E stuff. So we notice we have a lowercase e and an uppercase e. How do we implement that? Well, we can do one of these, right? That's very simple, right? We don't have to have that, right? Because not all of them have this regex, this E thing. But let's do it like this. Let's put it in parentheses. Now this last parenthesis thing is going to match scientific notation, right? So we notice we have the E's. We have to have one of them to be in scientific notation. Now we don't have to be in scientific notation. That's why we have this question mark. But we have to have the E's to be in scientific notation. That's why we don't have a question mark there. Now we have to match a plus or a minus, right? We don't have to match it, but we can. You see the one at the top doesn't have a plus or a minus, but the two below it do. So we're saying plus, minus, and then a question mark. We can have one, but we may not. Right now we have to have a digit. Because it doesn't make sense at all to end a number with E and not put a digit after it. So what we're going to do here is we're going to say G plus 1 or more. Boom. We come back, we run the test suite, and we don't get any failure. That's it. Any questions on that live coding example where we figured out how to parse a floating point number with regex?
In JavaScript, like in Perl, you can I can't remember how, but you can separate out your regexes into multi-lines and make them more clear. Can you do that in JavaScript?
Perl is substantially better with everything when it comes to regexes. To the best of my knowledge, that's actually the X flag in Perl, and I think it's insane, but JavaScript, to the best of my knowledge, doesn't have it. This is not something every language has, but it's Java, white space, ignore, or what do they call it?
Probably just multi-line.
No, it's because I don't want to change the matching semantics of it. I just want to.
Maybe the thing I'm remembering is that you would put the regex in a variable, and you would quote, and then dot, and then on the next line do another one. Maybe that's what I'm remembering.
Inside a single quote, you go to the plug at the end, and it goes match.
Oh, okay, there you go, yeah.
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 Because of the X flag at the end, it knows that there's
That's right.
Which is in the middle, and it's inside the single quotes,
Mhm.
so it knows what's going on. So I don't think
What they're talking about is Perl has a very intelligent way to make regexes maintainable. For all the shit people give Perl for being unmaintainable, this is one case you can give where Perl does the right thing. Regexes are a big part of the bread and butter of any programmer, and I would say that in no language can you find them to be as maintainable as they are in Perl. But yes, anyway, Perl, especially like 5.10 plus, has some really, really, really cool regex stuff. But because they even have like named captures. So if you remember, we're referring to everything with $1, with $2, and all of that crap. Perl actually allows you to name it inside of it. So you can name it inside of it and then refer to it by its name later on. I think it's called a name capture. But yes, really cool stuff. JavaScript lacks a lot of it. Sorry. Okay. Last time, any questions on regexes? Okay, moving on. We're done with that. That was our 30-minute regex review. Okay. Modules. I am not going to focus too much on module creation, right? And I think the big reason there is simply because you're going to be using modules, and hopefully you've maintained someone else's or looked at their code. And also, there's another good reason why I think focusing on creating modules is a big waste of time. JavaScript has something gigantic in the work right now. It's called ES6 modules, and they are almost out. So if you use Node, you actually name the file .mjs, and you would name the modules.mjs, and you would use a totally new syntax that I don't think is covered in the book at all. So teaching you the old syntax is kind of a waste of time. But we're going to go through some of it. I'm going to try to flash through some of this code because there's really not much code. You'll notice how much bigger the scroll bar is in this one than the last one, just because there's simply less scrolling I can do. So here what they're showing you is they're showing you encapsulation, right? So they're showing you that this guy right here, constant name, this thing at the top, this isn't available to anything. That's not the function, right? So when you call this weekday, right, it returns a function. It returns an object. And that object has two functions on it. They have access to names, but you don't. This is primitive modularization, right? And it is primitively modular because this thing names can't be, nothing else has access to it. So because nothing else has access to it, it's private, essentially. And that's the point here. The point is that you can hide something using this pattern. So what's not important is how this pattern is done because it's changing a lot in JavaScript. It is important that you kind of see and understand it. So we're going to look over here. Common.js, this is the way we currently do things right now. Again, this is all on the wayside. It's even. This is it. This is what they're going to look like here. And I don't know that it even shows it. So that's what module, by the time this third version of the book is even out, because I think it's still in development, I imagine this will be the dominant method of doing it. So what we do, and this is, I think, the way a lot of languages have moved to this kind of syntax. We have import ordinal from ordinal, and you can see here, this is what it would look like on the inside. You would have export, and you would give it whatever you're exporting. This is going to export the function date, which you can import with a similar syntax. This is called the ES6 module syntax. This is the new thing. We're going to go over some examples of that, but the pizza is here, and I'm not going to compete with that. So let's eat, and then we'll come back and we'll handle it.
You gotta have the pineapple.
Browser 2, the second after everything supports it. You say essentially import f from your name of your file. You're going to say what you want to import from that file. And then you simply say in the file export default or export whatever. Right? It's kind of all there is to it. And then all you do is, right now you currently have to use this flag, which is node -- experimental modules, and then the name of the module. Right? After you run that, you get this warning telling you that this is still experimental code, and then you get good. And the reason why we get good is because that's what my function does. So most of the stuff in the book is about writing modules in formats that will no longer be in use, probably within the next year. Right? So they're all kind of going away. And this is the standard format. So we're going to skip a lot of that. And what I would rather show you is how we use something like Node, which is how we're going to use modules other people create. Because you probably don't have enough experience to contribute anything useful to JavaScript yet. So the real question is, how do you make use out of stuff others write? Right? Does anyone have any experience with Node? Anyone have any experience with NPM? Used it before? Very cool. Right, so NPM fits into a class of things, for those that have never heard of it or never used it, which is essentially a package manager. Right? It's like CPanel or apt or yum or whatever else you're used to, in that it goes online, it downloads a package from a centralized repository, and it makes it available to your local code. You can use it pretty simply. So in Node, we would use that for all kinds of things. Now, the two most popular tasks, I would say, for JavaScript are writing web servers and writing things that crawl web servers. When you're talking about server-side JavaScript, right? If you're talking about client-side JavaScript, I'd say your two most popular things to do, or, well, the most popular thing to do, is to use something like React or Angular. Right? That's the majority of modern JavaScript client-side development. You're using NPM to install React or Angular, and then you're using the ecosystems that those two worlds provide. Okay? So if we're going to do something like, let's try to live code, and we're going to try to create something that starts a web server, like Express. Right? So we know what the go-to method is. It's Express. So if I come down here and I say Express JavaScript, right? You see it right there. A fast, unopinionated, minimalist web, whatever, marketing text. So it gives you this command right here, right? And the command is simply npm install express -- save, right? So this is kind of cool because -- save makes it to where it enters that module into something called a package list. In Perl, they call it a manifest. And that makes it to where in the future, when you want to install those requirements, you just type in npm install. It takes care of all the rest of the work. So you're not making a make file. npm is making and maintaining a make file. Right? So if we do something like, let's say we want to get this up and running, we're gonna create a copy of Express and make it working. First thing we do is we run npm init, and essentially it's going to give you a bunch of things you can change. Of course, no one ever does that, so just say yes to everything, and then it's done. That's simple. And now we're going to run this command that we just got off the Express website, npm install express save, and it's going to do all of that, right? So it went online, and it added 50 packages, because everything in JavaScript has to add at least 50 packages, from 47 contributors, and it audited 119 packages. JavaScript has something, to my knowledge, that I want to say no other scripting language has. Certainly, to my knowledge, Perl doesn't have it. And this is internal dependency pinning and auditing. So if a package is known to be insecure, right, you can tell not just whether or not you're using that package, but whether or not anyone is using that package in your project. So that is, it's not really the mode that most other languages work with to begin with, but that's a really cool feature. So oftentimes you'll be using a module that'll be largely unmaintained, right? And then that module itself will be requiring code that's old. So this will flag it for you and say, look, we know that there's a security vulnerability here by way of this, which is using it. And you can say, well, what is how big of a threat is that? What do I do on it? So NPM's auditing mechanism is really, really cool for making sure that you're not running old shitty code.
So with that said, look, added 50 packages from 47 contributors. Okay, what does audited 119 mean? I mean, is it warning us here, or I can't tell?
It's not warning us because there's no errors. So if you say something like npm help, right, it'll tell you all of the options here, and you'll see npm audit as one of those options. npm does a lot of stuff, right?
Okay.
One of the things it'll do is it'll tell you everything that's outdated. Most things will do this. You can run npm outdated, and it'll say nothing. Nothing's there. You can say npm ls, and it's going to tell you all of the different packages that you have and how they're running. So if we were to talk about this for really, I mean, I don't want to go too deep into it, but essentially, most other languages install their packages globally. So you essentially have to have something like root access, and then those packages get installed where everyone can access them. JavaScript installs all of your packages locally. In my opinion, it's a much better way of doing it. Because it does this way, everyone can have a different version of a package. You can install a project that requires one version of a package and run it side by side with a project that requires another version of a package. And that is the default mode in which JavaScript runs, Node runs. Not the default mode that like Perl runs. I know we have a lot of Perl users in here. Tends to be, if you're going to install something like Moose, you go sudo cpan Moose, right? And it installs Moose globally for everyone. Puts it all in user lib Perl or whatever, right? That's one way of doing it. This is the other way of doing it. You're going to see here where it says deduped, right? Deduped means that this package, that this version, was usable by more than one component. So it made a note of it, so it didn't have to download and install it twice. There's a lot of packages that can be used by more than one component. But to answer the question, if you go npm audit, it's going to tell you here is your security report for all of your different things that you have installed, and all the things they have installed. And it'll detect vulnerabilities based on whether or not those packages are known to be vulnerable to something. Right?
Okay.
Okay. So now what we have to do is we are going to run. We've just installed Express. We need to get something up and working. So best way to do that, jump to the Getting Started guide. Most modules in JavaScript have websites. Unfortunately, most of those websites don't tell you anything that, like MetaCPanel or whatever wouldn't tell you. But we jump here and we're looking now for sample code. And it says npm init. We've already done that, right? We already created our app. We already installed Express. We've already passed this part of getting started. Now we're at the hello world part. So it's going to say here, they are using this thing called Express Generator, right? So we're going to go ahead and install that too. It's important to note that I have never used this before, but I want everyone to understand how this works. Right? So now we have Express Generator, and what I can do is you can say Express H to make sure it's installed. We know it's installed. Now we're going to create an Express app, and we do it just like this. Yes. Now we have our Express app right in here. So if I go to the next line, it's going to tell us how to do it. You can run npm install, and it's going to download all the prerequisites. Remember, we just went through what npm install did. I said that you can create a manifest, right? And then you run npm install to install all of this stuff in the manifest, right? So what we first did is we installed Express. Then we installed this thing called Express Generator. Express Generator makes us an app. And after it makes us an app, we run this command npm install, and it downloads all of the stuff that app requires, right? npm install. Da-da-da. Okay. And then the very next thing we do is we run this command, right? This is going to get the app up and working. Now it's saying right here, my app is listening on port 3000. So I'm going to say localhost 3000. Welcome to Express. So now we're using someone else's code, right? We built a web server with JavaScript. We're using someone else's code, and we're listening on port 3000. Right? Now we can start diving in, and we can take a look at how that code works. In my opinion, this is more important than the normal chapter about how to create modules in an old-fashioned way. So we're opening up app.js, and we can see what this code does, right? Get it up a little bit, make it a little bit smaller. Okay. So here's the typical pattern right here with Express. App.use / index router, right? App.use is going to listen to all things on this route, and it's going to call index router. It's going to listen to all things on this route, users, and it's going to call this users router. Okay, well, what are in those, right? We've got to take a look at that. So we're going to go tab new, and I'm going to look through this. And now if we go down here again, we can see that this is index router. Index router is right here. It's under routes index. So I need to open that file. Routes index. Well, that's the index one, right? So this is actually what's happening when we load that index page. Come over here, we're at localhost 3000. Localhost 3000 is right here. This is what's getting caught. It's called an index router. Index router is over here, and we're saying when we get a GET request, right, we want to call response.render index with this thing, title express. And that's the code there. So if I change this, right, let's say I change it to Evans Express, right, and come back, and I hit, well, we got to restart it. Come back and hit refresh, you get Evans Express. Right? So that's how that kind of hashes out, right? So now we've already got the web server up and running. The question is, what do you want to do with it from here? This is just an example of how you navigate to figure out what you're going to do, and then you know, go through the docs and copy and paste code until you get up a boilerplate. From here, you're ready to run. This could easily be turned into something that was making your own API. Now let's add a path to it, and we'll add the path that returns a JSON object or something. Right? So we're going to come over here. We're going to say response.get. We're going to say JSON API. And now what I want to do is I think response.render. Let's take a look at the guide. Response.json sends a JSON body request. So I open up the doc, I look for JSON, and I see rest.json. Rest is response, REQ is request. So I can say it just like this, rest.json, give it a body object, right? So rest.json, and then we'll say here. Now I'm going to come back, we'll restart it. And we come down here and we're looking now for JSON API. And there we go. That's the pattern with JavaScript, right? If you've never seen it. I'm trying to show you browsing docs, get something up and running. This is your common task, right? So if we go back to the code and we look at how it's doing the module system, you're going to see all this stuff up here. Require. This is the common JS method. You can look at that all up inside of the Eloquent JavaScript. This is the old way of doing it. This will probably change pretty quick, right? But that's how it looks. So we're pulling in here, we're requiring the index route. We come over here, this is the file, and this is how we make use of it. This whole file exports one thing, index router, and that's the router. This is like Perl's Dancer emoji framework. come from that world. Cassandra stuff. Okay. So we could do another task. We could do something like request.js and make something that crawls a website, right? If anyone has any ideas of something they want to do, we can try to like live code it. We can find a module that does it and get the job done. But generally speaking, you're going to find a module that does the work that you want it to do, and you're going to find that module by looking it up on npm. You're going to type in npm install the module's name. It's going to pull it down, and you're just going to simply import it. And usually there's docs that will show you that boilerplate to do it. It'll be right on npm. And you're just going to use the same JavaScript you use throughout this course, whether you want to use functional programming or object-oriented programming, however you want to do that. Make use of that module. Cool. Any questions? Marco, any ideas? Anything anyone wants to see? Okay. I think at this point we're kind of done with the class. There's really not much more to do, right? There's one other option that we can do, but it's not related to Node or JavaScript on the server, and that's JavaScript on the client. If you guys want to learn that, we can certainly do it. My thing is, most of that is going to be specific to website development. So it's totally up in the air. A lot of people aren't going to be going into website development. They're going to be doing systems admin, that kind of stuff.
Look at it, yeah.
Yeah, why not?
You guys want to go down that path?
Sure.
Yeah. I can start you down that path. I'm not sure that,
We can cover you up.
what we're going to do for that is you jump down here, right? And you can see here we have async. Well, we have one more thing we can do. We can do asynchronous programming. We
Yeah.
go through a little bit of that.
That's good.
But then we're done, right? So asynchronous programming. Let's hit this up. This is actually this looks to be a pretty short chapter too. There's a little bit of code in here, but it's not long, which is good. Okay, so here's something. Does anyone know what synchronous programming is and asynchronous programming? Anyone want to try to give a definition before I define it?
Yeah.
Anyone but Ed, because I know Ed knows it. I'm 100% sure.
Yes.
Okay, give it a shot.
Like synchronous, like you're running some code and it has to follow in a line, and it's nothing runs in parallel. And asynchronous, you could have branches of code that run in their own process, or whatever that's called, and it can run simultaneously. It can run in parallel, and you could have more than one branch. Like the program doesn't get stalled. Okay, in synchronous, it could get stalled by something, and it could be waiting there when it doesn't really have to. When it could be running other code and doing something else. So that would be one reason to have asynchronous. I know that's not a really excellent thing.
I'm going to let Ed explain it, but not yet.
Okay.
Anyone else want to give it a shot? Anyone? All right, Ed. Oh, wait, here we go. Karen, give it a shot.
It's when you are able to work on multiple executions at one time rather than having to do one, wait for it to end, and then wait for it to end.
There's definitely a huge degree of truth to both those definitions. Let's hear Ed clean it all up.
Okay.
I don't know if I can top Karen's answer because it's actually a really good answer. You cannot make assumptions about when things finish because certain threads of execution, certain processes or handling of events may run faster or slower than other ones within the same system.
Robert, callbacks. Definitely, it's a part of it, but it's not the only way to skin the cat, right? So that's the one thing I want to be careful of, is that we don't want to think of any one way to achieve asynchronous programming as being the only way. There's a lot of ways to do it. That's why I think that both of those answers here are more of what I was looking for. Blocking is certainly a huge part of it, right? But blocking can happen at all different levels, right? I think the clue here, the real kicker here is that with asynchronous programming, what you want to do or you want to strive not to do, right? And you'll achieve it to a great degree with ease using Node. So in Node, unlike in most languages, and I really can't think of another language that does this, though I'm sure there's a couple. In Node, the base libraries are asynchronous. They're all asynchronous. So if you use something like Perl, you need to use something like Poe or asyncio for the Perl users. To use something like Python, you have to use something like twisting, right? These are different libraries that provide you the ability to run asynchronous code in the language. But the language itself, off the shelf, has no ability to do that, right? So the libraries are often responsible for providing that. With JavaScript, with Node, everything has asynchronous and synchronous methods. And you can at any time just call on those asynchronous methods and get full, well, almost entirely run a program that runs asynchronously. It's very easy. That's really the competitive advantage that Node has over everything else. So people say like, well, what do you like better about JavaScript over Python? My answer is almost always nothing about the language. But Node is really enjoyable to work with because it does everything right off the shelf, you know, and everyone is using it. And with Python, I find most of the people aren't doing it the right way. Most of the libraries aren't doing it the right way. Then my code is asynchronous, but their code isn't. Their code's blocking or whatever. You have a mess. So one of the things we're going to go through here is how this happens. You have to understand how Node achieves this because there's more than one way to skin a cat, right? So one of the ways that Node gets this done is with what they call an event loop. And I have not pre-read this chapter, so I have no idea how they're talking about that. Right? Okay, so they jump us right into callbacks with Ch10, which is a good method. So when you do something like this, you call a function called setTimeout, right? You're giving it the timeout in milliseconds, and you're giving it a function to return to when that timeout is reached. That's a callback. And we covered this a little bit when we covered closures, right? Because I said when we covered closures that the difference between a closure and a callback is minimal, right? Normally you use callbacks when you're talking about asynchronous programming, and you can use closures even if you're talking about synchronous programming. Closures are a cool trick, but they're not. Callback is usually the word you use when you're talking about asynchronous programming stuff. So what we have here is 500 milliseconds after you run this command, the setTimeout. That's going to run. But how is it going to do it, right? There's a loop running in the background for Node. It's called an event loop. And what that event loop does is allows you to put things on that loop at different times, right? So when you say you want to have something run in 500 milliseconds, then what it's going to do is every time it goes around that event loop, it's going to say, is the 500 millisecond expired? Is it expired? Is it expired? Is it expired? And when it does expire, it's going to put it on the loop, right? There's different ways you can do this, but this is generally speaking how you can think about this. So when you run it the first time, the setTimeout, it returns instantly. But 500 milliseconds later, as your Node program is churning and doing whatever work you want it to do that's not related to this, that's going to go on the loop, and you're going to see it. Okay, moving down, we have another example here, read storage, right? So read storage is showing you how we can use something like asynchronous code to read through something that is in and of itself not fast. When you do something like talk to a database, or you talk to a website, that doesn't happen instantaneously, right? In fact, it's probably one of the slowest things your program will do, is talk to something outside of the program. So when you're running a program, your computations are like a footnote in the amount of work the program does. The vast majority of time, human time, your program would spend is talking to a server, you know, wherever it may be. So all of this, in this example, read storage, is done when you don't see it. You're calling a function read storage, right? And you're giving it two things. What you want it to read, this food cache, and what it's going to do after it reads it. When you call this read storage, it returns instantly. But this second thing that you're providing here, this cache, this is actually a callback, right? This whole thing that you're seeing highlighted right here, this whole thing is a callback, and it doesn't run until the storage is read from. So Node can process all kinds of other crap in the background, whatever work you need to get done, while you're waiting for that storage to return to you. So you have an event loop that's churning in the background, and you have the ability to say, when you're done with this, make this the next thing you do. and Node takes care of the rest. Right? Now compare that to a synchronous method where you say do A and then do B. While you're waiting for A to return from the storage, nothing happens. Whereas with Node, with this callback syntax, even though it's a little bit more complex, right? You're able to do work while this is happening. You can put stuff right here. You could say here, very complex computation or whatever, right? And then this will actually run before read storage's callback will run. So this will go on the event loop. It'll say read storage, food cache. It'll start that process. And then when that process is done, this will be pushed onto the event loop to run. But all before that happens, before that iteration of the event loop is even done, this code down here will get started. This code will run at the same point in the event loop as bigoak.readStorage. One tick after, right? Okay. So we're just showing you more examples, right? Here we're sending cow pasture note, let lady cow at 7 p.m. and we're giving it this return back, this callback rather. So this callback is going to essentially print out note delivered, right? Here we're doing define request type. We're doing the same thing, right? These are just basic callbacks here. Down here we're seeing a promise. This is the first time we've seen these. This is also part of asynchronous programming. So with a promise, right, it essentially changes the method in which you're writing asynchronous code. We had, Robert mentioned earlier, callbacks, right? And I said it's not the only way to skin the cat. Promises are another method of doing that. They totally obscure the fact that there's callbacks anywhere. And with a promise, you have these things called thenibles. So we say here, we can say afterward, dot then this. And we would chain it. We would say dot then whatever else, you know? And then dot then whatever else. This totally gets rid of the whole callback notion. You don't see the callback there at all. You just provide a function to the then. And as long as that chain is successful, one will run after the next, after the next. And the reason why we do this, we use the dot then stuff, right? Is because when we call back, I want to come back up here to an example like this, right? Each time we do a callback with this method, we have to indent. So if we had something here that was doing a callback, we'd have to indent further. And if that thing was doing a callback, we'd have to indent further, and so on and so forth. So you have this indentation style with callbacks where it's not flat, right? It's essentially, it becomes more difficult to maintain. So the promise method was made to get around that. In the promise method, you can keep everything flat. Because all you're doing is saying dot then, right? You can arrange it any which way you want, but here's the promise method. You'll see here, look how it's flat. Dot then, dot catch, dot then, right? There's no additional tier with every time. Okay, the request stuff, let's look at this. This is
You can mix them together if you do want
You can mix them together if you do want indentation. The thing is, like, just so you know, Mike, by the way, is from the Free Code Camp group. Welcome.
Hello.
We finished the chapter on regexes and we finished the chapter on modules. So we had like an hour left, and now we're just trying to cover some of the stuff on the asynchronous thing. And that's where we're at. I think what we're going to do is end it a little bit earlier because I would like to read this chapter before we cover it all. But this is the last one we can do. So I'm going to cover this, and then I'm going to show some examples of it in the next class. And then I think we'll make a decision about whether we're going to do define side stuff or not.
Since we went over regexes today, did you want to like give some examples of regexes using grep?
That's a great idea. Let's do that instead. Let's not just show grep. Let's show some other regex implementations in other programs. Right? Grep is a great example. Okay, let's take a look at that. And it also fits really well with the group because the group is supposed to be. And I'm cool with that. Supposed to be about not just JavaScript. So here I talked about regex as being a tool we can use everywhere, right? And we only showed one implementation of it. And Marco was right to raise in the last class that this would be a great point to show other implementations of a regex. So Marco showed grep grep has inside of it, if we go man grep, right, we can see here that grep has two different implementations of a regex. They have this thing called Perl regexp, which is very close to the one that JavaScript uses. And they have another one called -e, which is extended. And we really only care about the Perl one, right? So even if you hate Perl, the flavor of Java or regexes you see in most places is essentially called Perl regexes, Perl compatible regular expressions. So we can take it and we can say something here. Like, let's say we have a file. We're going to create a file test, and it's going to have in it foo. And let's T1. There we go. Well, that syntax should have worked, but it didn't. So now we have a file that has foo in it 4 times. And if I want to create one that has bar in it, and we're going to create one with baz. So we have 4 foos, 2 bars, and 1 baz. We can grep all of these files here using this P syntax. Grep foo.
It's capital P.
I'm stupid. You're right. Capital P. Now we see we're looking at all of these files for the regex foo. But here's the thing: we created foo bar baz, right? 2 of them start with a B. We can just as easily do this. Well, it's showing ones that don't match. Yeah. Marco, why is it doing that? Marco, this was your idea. Marco likes putting me on the spot, as if I don't do this enough to myself. I have no, I didn't know.
You're gonna love this, but I never use, I seldom use -p. I use regular expressions when I use grep.
Okay, so Marco booby trapped this one. Marco, well done.
He always does that to finish the class.
Oh, because it's B, 0, or 1.
It's
You
what?
got a star. B, 0, or 1.
But
So
foo
there's
has
no-
no B.
Correct. There's no
Star,
0. There's no B.
zero,
Therefore,
star matches
do-
0. Yeah,
You
that's
do a
exactly.
plus.
There you go.
There you go. That's the reason. Well said.
Well said.
So there was our mistake. Our
Nice.
mistake was that B star is 0 or more Bs. And of course, 0 or more will make it match every file. Precisely.
It was working correctly.
Good catch. It was working correctly. So here's how we can do this, right? Let's go back, and if we type in foo, right, we see it matching all the foos. If we want to match the bar and the baz files, I can just do b dot star, right? And now we get bar and baz. Okay? Now here's I think what I was actually confused with is that the E method for grep doesn't work like that. The E method is the glob method, right? Is that right, Ed?
Yeah, that's what I was gonna say. You're used to, in the shell, a star means anything with else. Like
Yeah.
follow.
It still does.
I don't know that.
No,
It's
no,
still-
you don't have
it's
the
still-
expression
it's
GREP.
Yeah,
It's
just
not a
like-
glob method.
Okay.
So you're basically saying 0 or more B's. Either way.
Yeah, it's still.
I think the E has more to do with,
Like if you
Perl
were
has
just
more-
using bash,
Yeah.
then that's.
yeah, if you were just doing an LS with bash, it'd definitely be glob.
Okay, yeah. Okay, they're all right, and I was wrong on this, and Marco
So-
got it wrong, and he put me up to
So
it.
E is for the extended regular
Capital B.
expressions in grep. It's where you escape out the special characters.
There we go. Okay, so we look here, we can see bar and baz, and we're gonna make this look a little bit more like a regex. We can even do this, right? BA, and now we're still matching. If we wanna do bar baz, we can do that, and we're matching all the content inside the file. This is all the same syntax you've already seen, right? We could say something like, if we wanted to have 2 A's in there, we could do that, and of course we match nothing.
It's worth noting the dot star, you're not doing anything there.
The what?
Well, the dot star, you're not matching on the beginning and end of the strings.
Will the dot
The
star?
second one?
Well, the B dot star and BA dot star. Because you're not matching the beginning and end of the string, so
Well, you don't have to.
You don't have to. No, it's not, it's unanchored by default. Is that?
But I was pointing out that that's like superfluous or not necessary.
Yes, yes, yes. You mean you could do that?
Right.
Yeah.
Yeah.
And you can
So-
also do plus.
That's exactly right.
If you had the O in there, you could theoretically do something like getting all the
Yeah.
strings in there.
Although the plus is not your
Could you correct that?
which would be
O is something gravity is element.
Okay.
Format.
So the point here is that you can use grep, and what grep is going to do, take care. Grep is going to search inside of every file for the regex you provided. That's really cool, because if you know regexes and you want to search in a ton of files for a specific thing, you can now do it very easily with grep, right? Okay. And by the way, the normal method of using grep, you would just type something like that, and you would say in the file, and it would come back. New error. So that normally it doesn't use the regex, so you can use regexes with this -p. That's what we're doing there. Let's talk about replacing things, right? If you want to replace something in a file, you can use sed. So if I want to say here sed replace, if I want to replace all bars with bazes, right? You can say here bar baz, and now when I do it on T5, you see baz returning. If I want to replace all B's with baz, I can do that, right? You can replace whatever you want with sed. Sed gives you the ability to replace things. Doesn't change the file by default, but it can. But it gives you the ability to change the contents of the file, right? So if you ever say, I want to run this regex, find these patterns and replace them with this pattern in a whole file, you can use sed for that. So you can use grep to search through a file, and you can use sed to replace things inside of that file, right? So that's all pretty cool. There's all places you can use regexes. Let's open up the file and we'll show you one more of them. If I take one of the files, Vim T1, this is Vim. This is the editor I use. You can all use a different editor. If I want to, let's say I want to replace all of my foo's in the file, I can do that very simply. Search for foo, replace with bar. And they all become bars. Vim allows me to write a regex and run it on the entire file at the same time, right? You can find all things, let's say I want to find all things between a 1, this is a Vim syntax here, between lines with 1 and a 3, and replace them with that. With Vim I can do that. I can say 130. Maybe I can't do that.
That's lines 1-3.
That's what?
Well, if you take out the half percent, that would be lines 1-3.
There we go. That's the issue there. Okay, so wait, here's how we do it. I'm sorry. It's like this. There we go. So now I'm replacing only the things that are found between the lines that have a 1 and a 3. I'll show you that syntax. By the way, sed supports this very same syntax. This is saying look for the lines that start with 1, or that have a 1 in them rather, and the lines that have a 3 in them, that has a 3 in them, and replace all of the foo's with bars. Right? This is just more uses of regexes. They're all over the place, right? And if you use an atom or something like that, you're going to have all of those types of options. So the point is, learn regexes, because they will save you a ton of time, and they're everywhere. Anything else you want to add to that, Marco?
Most commonly, I think I use them searching through log files.
Very good for that, yeah. Looking for an error through a log file, grepping through the log file for error.
How many times did it happen?
Yeah, super useful. In fact,
If you use that shit.
Keep in mind that, like, if you get into the big data realm, grepping through log files is something that Hadoop will distribute for you across huge data sets. And so it is incredibly useful, even if you're, not just doing like one-off sysdig.
yeah, I definitely agree. I mean, look at that. Could you imagine having, let's say you had a bunch of them, 1s and 3s all over the places or whatever. I mean, that type of syntax is very simple to search for this, in between these 2 lines, do all this. Here, let me show you something else we can do. Let's say that I take this line right here, right? Vim can do. And by the way, this is also the same syntax that sed has, right? Let's say that you want to delete lines that have baz in them, right? Now, baz can be anywhere, right? If I want to delete the lines that just has baz in them, I can simply do that with this. I can use G. So G is going to find me all the lines with Baz, and I can delete them like that. And they're gone. That's searching out Vim and saying whatever the line matches this regex, delete it. Okay, but Vim is even cooler than that, right? I can say with Vim, right, you can say search for all of the lines that don't have Baz in them. That's an inverted match. Right? I'm just saying, I just want you to see like regexes are everywhere, right? And you can do all kinds of really, really, really cool stuff with them. This is just the editor I use. You all have your own crazy editors. Okay.
Why do you choose Vim?
Because that's pretty insane.
Because
right? I mean, that's pretty cool.
You like the feature set of Vim.
Yeah.
So apart from the features, which Vim's got more of them than you can shake a stick at, there is one really good reason for everybody to learn Vim. As opposed to every other text editor you're probably going to run into, VI is guaranteed to be installed on any Linux or Unix-based system. It's actually part of the standard base of what is a Unix-based system. And so if you uninstall VI, you no longer have a Unix-compatible operating system.
So look at this one. Here's another one for you. You said, because beating a dead horse is always a blast, right? This is going to search for all lines that have the word Baz in them. And if it finds any lines with the word Baz in them, it's going to execute a regex that looks for all of the patterns what and replaces it with Evan.
Evan ever?
So that's looking for specific lines that match a pattern, and then searching for a pattern and replacing it with something else. And if I wanted to find all lines that don't match Baz and replace all A's with B's, we could do this.
Capital A.
Do lowercase.
Yeah,
Capital A.
There we go. Yeah.
Fun point trivia, that's where the name grep came from, right?
That's what?
That's where the name grep came from.
Global regular expression, yeah.
G/RE/print for the P.
Yeah, that's right, yeah. That's exactly right.
Oh, you're going to show that V there, and you were talking about grep earlier. Know that grep has a -V on it that says invert to match.
That's right.
And behaves exactly like this does.
If you're going to do anything with Linux systems administration, it doesn't matter what it is, it would definitely be in your best interest to learn grep in and out.
Yeah.
You know what's also interesting? This grep doesn't have paragraph mode, by the way. AIX grep has paragraph mode, which is something you may miss. It's pretty nice. Like,
I think it's under egrep.
I don't see.
No, not -E. There's a command egrep.
Yeah.
But doesn't that just run grep e?
It's pretty much just grep E.
Yeah, that's just grep e.
Oh, okay.
E grep, F grep,
You have any opinions on ACK?
or awk.
I think if you learn Perl,
ACK?
I know it. I use it still for field separation, but that's it. And for everything else, I'll use Perl. I don't see too much of a need for awk if you need Perl.
ACK.
I've been saying
act, which is like
like
Oh,
TCP
you mean the
acknowledgement.
source filter? That's written in Perl.
Yeah, it was written in Perl.
Yeah, I think
it's like
ACK is written in Perl, right?
I think so.
Yeah, I think-
I know there's people that really love Perl that use that more often than I do, but I for some reason I never found the things that it gave me that grabbed in.
ACK is amazingly cool. ACK is really, really cool. Because but that's a real coder like esoteric thing.
Like, what are the, maybe you can tell us the advantages of ACK over grep.
Yeah, my only preference is that the default is prettier. Kind of better highlighting in the output.
Okay.
But if I ever get stuck on something, I'll just go back to it.
ACK has intelligent code parsing. So ACK, if you give it something like a name, it will realize that you're parsing a C file, source filter for that name, and then prioritize function names over comments for that.
Huh.
It does all kinds of crazy stuff like that. Yeah, but it's horribly slow, so it's really good for source code. But I wouldn't want to use it on like a 5 meg log file. So yeah.
There's a coworker of ours that wrote him on CPanel. He wrote it in Perl, so it's on CPanel, and he called it GRE grep. And it combines. He tried to combine all the best of all worlds, making it fast, making it pretty output like ACK, and give it some powerful filtering options on it.
How's that go out?
I loved it whenever I used it. Only problem is it's not installed everywhere.
Yeah.
All right. Cool though. Does anyone have any other questions about regexes? I think Marco, that was a great contribution. We should definitely have included that in there. Anyone want to see regexes anywhere else, or any other questions about regexes or Perl modules, or rather JavaScript modules? Okay, cool. Well, we're pretty much done. So it's 8:30. We're all going to go.